Okay, we will discuss next the idea of finding the z value without uh, a diagram given. So let's solve these examples. Let's start with letter A. The key here is should be able to picture what the problem is telling us. That means that we must be able to translate this into a diagram using the normal curve. So let's start with letter A. Find the z value so that 53.98% of the area under the distribution curve lies to the left of the z value. Okay. So let's interpret this and translate this into a diagram. So this is 0. Okay, now what meant by this? 53.98% of the area under the distribution curve lies to the left of the z value. Our first thing we do here is to determine the location of z. And the key actually is here, no, in this phrase. Where do you place the z so that 53.98% of the area lies to the left of that z? Well, it says here that 53.98% lies to the left of z. Question is z located here? If z is located here, then it's not possible for the area to the left of z to be 53.98%, right? So that means that z must be to the right of 0, okay? Because if it is to the right of 0, then this statement is true. That is 53.98% of the area under the curve lies to the left of z. So meaning this is the region described in that problem. So question is, what is this value of z? Well, we have the total area given here to the left of z to be 0.5398. So again, before we can find for the value of z, we need to find for the area between 0 and z. Okay, but how do we find the area between 0 and z? If the area to the left of z is 0.5398, we know that the area to the left of 0, half of the normal curve, is actually 0.5, right? So to find for the area between 0 and z, we only need to subtract from this area the area of half of the normal curve, which is 0.5. So we have 0.5398 minus the area of half of the normal curve, which is 0.5. So we have 0.0398. So we have the area between 0 and z. We're now going to find the value of z. What is the value of z? We refer again to the table. We look for 0.0398 in the table. 0.0398. 0.0398 here. 0.0398 is corresponds to 0.10, which means that the value of z is 0.10. Okay, so that's 0.10 or 0.10. Is this positive or negative? Of course, this is positive because your z lies to the right of 0. Okay. Letter B. we have 87.90% of the area under the distribution curve lies to the left of its there's a problem with the statement here. Lies to the left of it. There should be a period here. Okay. 87.90% of the area under the curve lies to the left of the Z value. Okay. Letter B is actually similar to letter A because it says here that the area to the left of Z is 87.90%. So again, Z must be located on the right side of 0, right? In order for the area to be greater than 0.5. So the same procedure, we find the area between 0 and Z, and that means that we subtract the total area here, which is 87 or 0.8790 to the area of half of the normal curve, which is 0.5, and subtracting we have 0.3790. So what is the value of Z? This is the area between 0 and Z. Again, we use the table, look for 0.3790. 0.3790 here. Okay, this is 0.3790. That corresponds to 1.1 under column 0.07, so that's 1.17. So the value of Z is 1.17. Positive? Yes. Positive because Z is located to the right of 0. Last. What is the value of Z? So that 11.20% of the area under the curve lies to its right. Okay, we must be able to translate this again in a diagram. So question is, where do you find Z? Do you find it to the right of 0 or to the left of 0? Take note that the key here is not this word here, no? So where do we find the Z? For example, we place Z here to the right of 0. Is it possible, or we place Z here, is it possible for the area to the right of Z to be 11.20%? Of course, that's not possible because if it is located here, the area is already greater than 50%. The area to the right now is already greater than 50%. So Z must be located here so that it's possible that 11.20% of the area lies to the right of this Z. Okay? So that means that this is 0.1120. Okay. Again, our objective is to find for the value of Z, but to find for the value of Z, we need the area between 0 and Z. How do we find that? So we find the area between 0 and Z. To find the area between 0 and Z, we know that the area of half of the normal curve is 0.5. So we subtract from 0.5 this area here, which is 0.1120. And subtracting, we have 0, 8, 8, and 3, right? So 0.3880. This is the area between 0 and Z. So what is the value of Z? Refer to the table again. 0.3880. 0.3880. Where is that? Okay, there is no exact value, so what we can do is to choose the closest value to 0.3880. Is this the closest? There's a difference of 8. 3880. What about this one? That's already too far. 3880. See, the difference is 11, while here is 0.008. This one is 0.0011. Okay, so we choose this, which is 1.22. Okay, so this is 1.22, and this is the value of your Z. So that's it.